And this is one of the first organisms, a species called Sahelanthropus chadensis, that shows evidence of bipedality. And all we have is its skull. It's only about this big. It's not very big. There's a cast of its skull on exhibit in the Romney building, if you want to go look at it, along with some of these other hominins or this group of primates. One thing that we see, for example, in Sahelanthropus, well, first, if you look at a modern chimpanzee, this opening, the spinal cord goes up through there and connects to the brain. It's called the foramen magnum. This opening sits in the back of the skull in chimpanzees. Now, it would be really weird to have that opening at the back of the skull if you decided to stand up, right? Your head would be way forward. It just wouldn't be a very effective position. In modern humans that are bipedal, we see that the foramen magnum is about in the middle of the skull. And in Sahelanthropus, we see a transition. We see that foramen magnum moving toward the center of the skull, which is indicative of an increasingly bipedal lifestyle. Another really important fossil is one called Auroran tugenensis that existed about 6 million years ago. And again, you just have fragmentary material of this forest and tree-dwelling organism. But one thing that we do have are the femurs and the femur heads, which are at an angle, have shape characteristics that are much more similar to bipeds than they are other primates. And so this is generally also considered to be evidence for bipedality. Another early primate that was moving toward bipedality is this one called Ardipithecus. You may have heard about it or read about it. Ardipithecus has a really well-preserved skeleton. But note that it has characteristics that suggest that it was bipedal, but this was a bipedal organism that still spent a lot of its time in the trees. Notice that not only does it, look at how long its hands and fingers are, but not only does it have opposable thumbs, but it also has an opposable big toe, right? that it could have used for grasping. Ardipithecus is a really interesting transition between some of these earlier bipedal primates and really us. So again, it's a pattern in the rocks. The general idea is that bipedalism arose, and this was a bit of a surprise, because these earlier bipedal primates lived in forests. Right? They weren't out walking around on open savannas. They were living in forests. They were living in trees. And generally, they had a plant-based, a fruit-based diet. And the idea is that, if you can just stand up for a little bit of time up on your haunches, you can free up your hands to gather fruit for longer periods of time, and even take that fruit and perhaps take it to other members of your troop, if you will. And so that this selective explanation for why go bipedal is thought to be associated with fruit gathering, with diet. Likewise, our next major group of these bipedal primates, they existed from about 4 million to 1 million years ago. You may have heard of Lucy. She's part of this group. Is the Australopiths. And the Australopiths lived in a time when the forests were shrinking and the savannas were growing. And there wasn't as much fruit available. And so they started to rely on things called fallback foods, like roots and tubers and sticks. Less ideal foods, but it helped them survive. And the defining characteristic of this group of primates is really large cheek teeth, big molars, just huge molars. And we also see other features associated with the skull, suggesting, and here's a modern human with basically an Australopith by comparison. Look at how huge those molars are. And they had associated musculature as well to drive those teeth. And so if you're relying on rougher foods, you don't have the fruits that you typically want, so you rely on roots. You dig up roots from underground, or think of things like sugar cane. I'm not sure if any of you have ever chewed sort of a rough plant food, but man, it makes your jaw really tired and really sore really fast. And so we see adaptations in these organisms for a really tough plant-based diet. We also see evidence for improved bipedalism. They weren't just staying in the trees anymore. The skeletons suggest that they were finding those fallback foods largely outside the forest, out on the savannas. They were up digging up roots. They were moving from grove to grove, perhaps. They probably had to range further to get the foods that they needed to survive. Now we move from the Australopiths then to members of the genus Homo, our own genus. And our genus is also associated with the change in diet. The genus Homo and the features associated with it are largely associated with moving from almost entirely a plant-based diet. There's evidence that the Australopiths would also eat some meat too. But moving more fully into an animal-based diet and engaging in hunting and foraging. Really, what made humans humans, this is argued by much of the scientific community, is the transition to hunting. Not only did it provide meat, which is incredibly nutrient rich, a lot of proteins, but it also, when you're hunting, when you're cooperating in a group to take down large game, or even to scare away other predators from a carcass if you're scavenging, that takes cooperation, that takes thinking. And if you're tracking an animal, that takes thinking. You not only are using inductive reasoning to generate the patterns, but you're using deductive reasoning to see where those animals are going, to predict where they're going to be. And so hunting fueled the human brain and human cognition. We also see other modifications to the human skeleton. For example, humans have a tremendous, our shoulders are much different than the shoulders of, for example, chimpanzees. We have the ability to throw rocks and spears, unlike any other organism, with great force and with great accuracy. The mechanics, the biomechanics of our arm and shoulder are different than a lot of those other hominins, giving us that ability. And we see also modifications in the skeleton for walking and running and so forth. But we also see tremendous increases within the brains of primates when we get to the genus Homo. You start switching to that meat-based diet, or adding meat to that diet. And this is another way to think about it. These organisms were still eating fruit, they were still eating vegetables, but they were also adding another source of nutrients, right? They were also adding meat. They were basically becoming less discriminatory. They would eat anything they could get, right? Those our brains, they burn a tremendous amount of calories. Something like 30% of our total energy demands, daily energy demands, go to the brain, keep our brain functioning properly. And so they took everything they could get to support those really large brains. In fact, another thing that you see in organisms with really big brains is relatively small stomachs. Our food doesn't stay in the digestive system as long. We get the nutrients out of it as we can. We eat as much as we can. We keep the gut short. We don't spend as much energy supporting that because we need that extra energy. We need that energy to support our brains. Okay, and then we get to things like Homo erectus. Largely, these earlier hominins, these earlier bipedal primates all lived in Africa. That's what the fossil record suggests, that they were all in Africa. But at some point, around a million years ago or less, much less really, several 100,000 years ago, we start seeing evidence of some hominins, some members of our genus, leaving Africa for the first time, going into Asia, and ultimately, like the Neanderthals, moving into mostly Europe. They probably originated there. And ultimately, we get modern humans. Our species, in fact, Neanderthals are probably the only, maybe. There could be some other exceptions, but Neanderthals are probably the only species of the genus Homo that actually originated in Europe. Our species, Homo sapiens, the fossil record suggests originated in Africa. Maybe you've seen the papers recently, but they just found a skull in Morocco that was about 300,000 years old. A couple skulls, I think 5 of them, that were essentially anatomically modern, Homo sapiens. So we first see modern humans 300,000 years ago, but we do not see behaviorally modern humans, interestingly, until about 50,000 years ago. And what I mean by behaviorally modern is culture, exhibiting a tremendous capacity for culture. Things like art and music and sewing and a tremendous other things that are essentially all associated with behaviorally modern humans. And also, for most of our existence, we were hunters and gatherers and living in small groups. But then again, about 50,000 years ago, we started, we almost experienced enlightenment, right? Around 50,000 years ago. Before we move fully into the modern human story, I want to mention this, that for a very long period of time, for tens of thousands of years, our species, the fossil record suggests, coexisted with other species of bipedal primates. Modern humans probably certainly coexisted with Neanderthals. They coexisted with a little hobbit species called Homo floresiensis that lived in Indonesia, a group called Denisovans, maybe even Homo erectus, or things related to it. But the interesting thing is, for the last 25,000 years or so, we have been the sole surviving bipedal primates on the planet. But in the past, we coexisted with others. That's a really interesting thing to think about, and the interactions that might have taken place there. You probably know that some of those interactions weren't all bad. It's really popular now to send out your DNA to a company and see where your DNA suggests you're from. And a lot of those companies now will tell you what percentage of your DNA came from Neanderthals now, right? Which is also an interesting thing to think about. Now, again, around 50,000 years ago, humans really started to experience a lot of change. And again, we see not only the use of things like art and music and domestication and writing, we also see patterns within all of those things. We see changes in art, geographic changes in art. We see changes in domestication of plants and animals. We see changes in the kinds of musical instruments that people make, changes in patterns of writing, but that, of course, is history. Around 10,000 years ago, we experienced the agricultural revolution. 300,000 years ago, modern humans originated. For about 95% of the existence of our species, we were nomads. We were wanderers. And then about 10,000 years ago, we started to settle down. And we started to domesticate plants and animals, and we started to live in larger family groups, and we started to create cities. That's the urban revolution. This is a city called Eridu in Iraq. It's an ancient city. It's over 7,500 years old. And in Eridu, we see evidence for these hunter-gatherers building a temple on the hill. And at first sort of visiting it irregularly and then settling around it, in part to take care of it. We see this in other places too, like Çatalhöyük in Turkey. Other sites around the same time where people start to settle. I mean, this is even an idea of anthropology, that one of the reasons that humans started to settle down and farm were for spiritual reasons. And that's an interesting thing to think about too. And then, of course, we have the Industrial Revolution, and we have what's often referred to today as the Anthropocene, the age of humans, essentially. And we see continuous and constant change over this 4 billion years of history until today. We have modern humans and all their glory and diversity and language and culture. And so again, how do we explain modern humans, the origin of modern humans? Largely, science chooses to explain it as a